let's take a look at the product and quotient rules. What we're going to actually start doing now is really start setting up some rules that we can work with to take or to help us take derivatives, help make our lives much easier. So there's two primary things we want to get out of this. First, we want to understand the power rule and obviously the quotient rule. I'm sorry, I said power rule. I meant product. This should be product. Sorry about that. Okay, this is the product rule. If I take the derivative, d dx, of two functions multiplied together, f of x times g of x, is equal to f prime of x times g of x plus f of x times g prime of x. It's simply a pattern that you need to remember. And the way that I remember it is it's simply the derivative of the first, then multiplied by the second, followed by the derivative of the second multiplied by the first. So that's the way that I remember that and put that together. So let's take a look at the proof of this thing. d dx of f of x times g of x, the derivative of all of this. I'm going to set this up using the limit definition. The limit as delta x goes to 0 of f of x plus delta x times g of x plus delta x minus f of x times g of x all over delta x. That's just using the basic definition for a derivative. Now what I'm going to do here is use a technique that's referred to as simply adding 0. Because you know, if I add 0 to something, I don't change the value. I may change the form, the way it looks, but I'm not really changing the value. So I'm going to say that this is equal to the limit as delta x goes to 0 of f of x plus delta x times g of x plus delta x. Now this is where I'm going to add my 0. So I'm going to change colors here. I'm going to subtract from this f of x times g of x plus delta x, and then add to it f of x times g of x plus delta x. So you see, if I added and subtracted the same thing, so that's adding 0. And then I need to subtract, sorry I ran out of room there, f of x times g of x, that goes down there. And of course this whole thing is divided by delta x. Now the reason I added 0, I added the 0 that would help make this thing right. So now I can start factoring things out and end up with a limit definition that I'll recognize. So from this first piece right here, I'm going to factor out a g of x plus delta x out of both of them. So when I do, I'm just doing this first piece right now, I'm going to have the limit as delta x goes to 0 of g of x plus delta x times f of x plus delta x minus f of x over delta x. And then I'm going to take this other piece over here and I'm going to write that as a separate limit. So I'm going to add to this the limit as delta x goes to 0. And over here, I'm going to factor out the f of x. So I'll get f of x times g of x plus delta x minus g of x. And of course, that's all over delta x. So I broke this limit up into two pieces, and I factor out some components. Now, see, delta x on this, well, let's go to the set first. As delta x goes to 0, this piece will go to 0, but we recognize this as being f prime of x. So I'm going to end up with g of x times f prime of x. Plus, over here, f of x doesn't have a delta x, so it's just going to be f of x times, well, this is g prime of x. And there it is. It's just a matter now of writing it because in a form that makes more sense to you. And I typically write it as a derivative of the first, f prime of x times g of x plus the first f of x times the derivative of the second. So that's the proof. That's why that thing actually works. So let's work through a couple of quick examples. So this is what I'm thinking of as f of x, and this is what I'm thinking of as, g of x. So I know I'm going to need the derivative of both. So I'm going to just go off to the side here, and I'm going to write, f prime of x is equal to 3, and g prime of x is equal to 2x. So now I'm going to put together. So the derivative of this is going to be equal to the derivative of the first, which is 3, times the second, x squared minus 3, plus the first, which is 3x plus 1, times the derivative of the second, which is simply 2x. Now, I'm going to leave it there for right now, but obviously you can do some simplification on this and collect like terms. I'll leave that to you, ... Go ahead and simplify. This one is the same idea, only this time I'm going to think of f of x as being x squared and g of x as being 3x minus 1. So again, I know I'm going to need f prime. F prime is 2x. And I know I will need g prime. So g prime is going to be 3. So what do I end up with? I end up with f prime of x, which is going to be 2x, times g, which is 3x minus 1, plus f, which is x squared, times g prime, which is just 3.